Okay, so I'm Andrew Crosby, and welcome to the Regenerative Insight Circle. Today we have Aarti Shah, who's going to present enhanced weathering. She'll explain it all to us. So thank you, Aarti, for agreeing to join us and dig into this subject a little bit more after one of our previous calls where we were all asking questions about it. So let me pass the floor over to you, and it's all in your hands from now.
Thank you. Thanks. And yes, this presentation that I'm going to go through probably for the next 20-25 minutes or so is based on a presentation I gave to some investors a couple of months ago, hence the disclaimer on the first slide. What I want to talk about today is, let's have a definition first, because these terms may, even when they're used, they can sometimes mean different things to different people. Then I want to look at what problems it solves. Anybody who knows me knows I always start with that. How effective enhanced weathering has been till now, with some examples covering different regions and different soil types. It's all about the soil. Well, it's more than just the soil, but you'll hear me say it's all about the soil several times, I think, today. And then where is it in terms of technological readiness? How could it be used going forward? So should we be thinking about using it on its own or as a complement to other negative emissions technologies? Where is it in terms of sort of legal and regulatory frameworks, and what needs changing to help enhance weathering go forward? And then finally, some investor takeaways, which I think for the perspective of today is really going to be some things that if you're interested in any enhanced weathering projects, the kinds of things that a sort of checklist that you could be going through. So I've already sort of introduced myself, so I won't go over that again. But first of all, what problem do we want to solve? And I think, the first elephant in the room is clearly climate change. And I think to put some numbers, and I'm going to be a little bit heavy on numbers initially, just to set the scene. But experts predict that by 2050, 6 gigatons, so that's 6 billion tons of carbon dioxide equivalent must be removed from the atmosphere every year. And apparently we've managed to remove all of 10,000 tons so far. So Houston, we have a problem. One significant contributor is our food systems. The contribution itself, the numbers vary depending on where you start and stop the clock. But with 9 gigatons of carbon dioxide equivalent emitted from crops and agricultural production in 2018. So I think secondly, how do we ensure food security for the projected 11 billion people by 2100 when we have a soil nutrient depletion problem, especially in tropical soils? And why do the tropics matter? Well, one, that's where most of the population growth is. Two, soluble fertilizers are often not affordable or accessible. And yield responses to, so there's the NPK fertilizer, which is one of the dominant ones used on the continent, or in Africa. The yield responses to that can become negligible or even zero if we keep ignoring these nutrient deficiencies. So we've got the soil nutrition problem. Thirdly, how do we dispose of mining waste? And this will become more relevant as I sort of go along and explain what enhanced weathering is. So what is enhanced weathering and how is it used? First of all, what's the natural process of weathering? The natural process is when silicate rocks react chemically with carbon dioxide in acid rain, and they're eroded. And the climate and vegetation actually regulate a natural rock weathering. So in a warm climate and with vegetation rooting systems and the fungi, that will accelerate carbon dioxide removal. And this carbon dioxide is locked away in bicarbonate form in limestone. And eventually that washes into the oceans, where that carbon is then stored in dissolved form, or it's locked away on the sea floor. So basalt is an example silicate rock, and that could be left over from volcanic eruptions, for example, in the East African Rift Valley, which is where I'm sitting today. So today, natural rock weathering accounts for a tiny 0.3% of global fossil fuel emission absorption, right? So not in its current form particularly a significant remover of emissions. The second thing is, so I've already mentioned this, agriculture being a major driving force of global soil degradation. And 10 million hectares of soil, of cropland, are being rendered unproductive every year. That's out of about 12 million square kilometers of total arable land. So the nutrients from these silicate rocks, as I said, contribute to the health of the crops and protect them from pests and diseases. So good thing. Enhanced weathering is where we take the same rock material and we pulverize it, or we crush it. And what that does is that creates a greater surface area, which means you can absorb more carbon dioxide. Ching, ching. At the same time, once you spread the rock dust on the soil, the good thing is it's not toxic and it doesn't leach. So, and at the moment, enhanced weathering, certainly from a UK perspective, is considered to be a TRL, technological readiness level 4. And that's through a number of lab studies and small field trials. However, that we still need to do a lot more testing of this, and I'll come on to that later. But that's why at the moment its potential has such a wide range, right? So it could be responsible for anywhere from 10 to 40% of greenhouse gas emission removals. Even at the small end, that's clearly much more significant than the natural rock processing today, or rock weathering today. And of course, the replenishing of those soils, combating soil acidification and putting back those lovely minerals is really the other aspect of it. So I think, to summarize, we spread these ground silicate rock powders over the farmland, depending on the soil, of course. It's all about the soil. The plants speed up that chemical reaction, and we're solving these 3 problems. We're resolving this issue around what to do with mining waste. How do we get more self-sufficient regarding fertilizer? That's clearly very, very topical. And how do we produce better and more food? I think what's really key here is that, unlike other negative emissions technologies, we're not competing necessarily with infrastructure and with land, right? Because we're already farming. And so, we're not competing both for land or for freshwater. And as I say, that infrastructure is already there. But that's one, I think, really key thing to bear in mind when you're looking at it vis-a-vis other negative emissions technologies. And again, the reason for the definition, I mean, when you read about this, very, very broadly speaking, very, very high level, in the UK, it tends to get referred to as a nature-based solution. In the US, I've heard it being called a direct air carbon capture solution. I think, at the end of the day, what it most certainly is it's accelerating a natural process. As I said, you're accelerating natural rock weathering, and that is considered to be geoengineering, which is, if you look at the Oxford Dictionary definition, that's deliberate large-scale manipulation of an environmental process that affects the Earth's climate in an attempt to counteract the effects of global warming. And on the screen, you see the Oxford University definition. And again, because geoengineering has sort of some level of negative press around it, and it could impact the uptake or the interest in enhanced weathering. I'm going to go through very high level the two major types of geoengineering. One is around greenhouse gas removal, which is the carbon side of it. Starting with things like planting trees and all the way through to sort of direct air carbon capture, and essentially there what you're doing is you're removing greenhouse gases like carbon dioxide, and you're therefore countering this greenhouse effect and soil or ocean acidification. The other side of it, which is probably even more controversial, is solar geoengineering, and that's where you're trying to reflect some of the sun's energy back into space. So that was really just to give you a bit of a feel of the broader spectrum of all of these solutions. Let's go back to enhanced weathering. As I was saying to the investors, you need to think about having a portfolio of technologies. And when you're looking at these technologies, you need to look at how ready are they for commercial deployment? What are some of the projections in terms of the costs for removing tons of carbon dioxide, both gross and net? How much carbon dioxide are you going to be able to remove? What's the maximum technical potential, et cetera, et cetera? I'll go into some of this in a bit more detail in a few minutes, but this is an example of the UK. In October, they published a report to the UK government and said, this is what we expect over a period of time to be the gross carbon dioxide removals. And you can see enhanced weathering has a very small sliver. That was assuming a rapid deployment at the top, and at the bottom you see the delayed rollout of it. Now, since then, quite a significant study has come out, and some of these numbers are likely to change. Certainly, enhanced weathering, I think, if anything, is going to go up. So, where are we today with this thing called enhanced weathering? I think it's fair to say that till now, there's been uses of it in different parts of the world. I mean, I've listed a few here. If you start with the idea of sort of cocoa farming in Africa, so small-scale farming has led to cocoa plants being applied with basalt. That was between 5 and 10 tons per hectare, and that led to higher concentrations of various nutrients, so potassium, magnesium, calcium, compared to the untreated control. And after 24 months, the treated plants were 50% taller and 60% thicker stemmed. Right? I think what's really important here is that there is that potential to deliver major wins from an agriculture perspective, because you will be lowering nitrous oxide emissions, you'll be reversing soil acidification, which limits yields, and you'll be reducing demands for imported fertilizers. As I said, soil matters. So at the moment, studies show potential of enhanced weathering as an alternative source of potassium and multi-nutrient tropical soil amendment. But it's not quite as straightforward as saying tropical soils good and temperate soils not good or less good. The benefits of temperate soils are still currently inconclusive. That said, countries like the UK are investing quite a bit into doing more research, and about 2.5 months ago, a major new study established that the UK could absorb anywhere between 9 and 45% of the atmospheric carbon dioxide it needs to do in order to reach net zero. And the 45% is more if new mining activity was to take place. But yeah, as you can see from here, there are field tests anywhere from New Hampshire to Mauritius, to the UK, and now Brazil is looking at it very seriously because they want to reduce their dependency on imported fertilizers. So I think some of the considerations, and there are many, but I think if I want to sort of summarize the things that people should be thinking about, one is, who's doing the research? And as I said, the UK's got 3 UK government funded trials in different parts of the country. There is a 4th trial in design stage. So this is a startup called Future Forest Company. And what's interesting about them is they're looking at co-deploying enhanced weathering, biochar and reforestation. And they've acquired land in Scotland and they're looking at how can they prove the benefits of these 3 at the same time. In the US, I think just around COP, the US government announced that it was going to ramp up its funding and get scientists to look at different approaches. With the idea of advancing technologies based on 4 things. And one is really to push down the cost of carbon dioxide removal to below $100 per ton of carbon dioxide equivalent for both capture and storage. Interestingly and importantly, they want to make sure there is a robust accounting of life cycle emissions. How do you make sure that your storage isn't just short-term and your costs aren't just looked at from a short-term perspective, but over 100 years plus. And also looking at really sort of gigaton scale removal. We are so very, very late. And we seem to refuse to, reduce emissions. So this whole thing about removing emissions and using all of these technologies is becoming really critical. There are some startups already. So there's research and development still happening, but now there are these startups. So just recently, a fund, the Frontier Fund, announced it had selected 6 startups to receive grants or pre-purchase agreements, which is advance payments for carbon removal in the future from the fund. And 2 of these, travertine and lithos carbon, are finding ways to speed up the natural process by which mineral weathering captures carbon dioxide from the air. Heirloom, I'll come back to Future Forest Company, I've sort of already mentioned. From a UK perspective, and given that UK is investing a lot into sort of R&D at the moment, they don't anticipate significant deployment till 2030. They think that in the decade following, there'll be sort of a slow increase of uptake, but then it'll really sort of ramp up after 2040. I mean, some of these timelines sort of scare me because I do wish we had a bit more of a sense of urgency on some of these things, but at the same time, as we'll talk about, there are risks. So, we do need to make sure that we're understanding what we're doing, but it's a little bit like we sort of have to understand what we're doing while we're doing it, because we've just left it so late. So earlier on, I spoke about the fact that, disposing of mining waste was one of the problems we could solve. So I do think that one of the considerations is, where does this rock come from, right? And I think wherever possible, it should come from mining waste, whether that's from cement or precious metals. And the question there is, are there already substantial sources from these existing mining activities? And can you use pulverized rock, which is already being produced by the aggregates and the mining industries? It's important to keep track of past mining, existing mining, and where and when new mining may be required. I think where, as I said earlier, sitting here in East Africa or across sort of sub-Saharan Africa, there are shallow deposits of basalt. So that's the first thing. Where are these rocks coming from? The second is, what are we doing to make sure that we're not creating unintended consequences around the environment and ecology? So how much carbon dioxide are we actually producing when we're quarrying, grinding, and transporting? And based on 2014 study, the transport and mining of the rock account for relatively little, but most carbon dioxide emissions come from the energy used to pulverize it. And then, what is the source of the energy? So energy demand could account for anywhere between 10 and 30% of the amount of carbon dioxide sequestered, depending on the size of the grains of powder the rocks are pulverized down to. Of course, using renewable energy sources will minimize this. But again, here's another number. According to the UK, crushing rock would need only 0.2% of UK electricity generation in the short term. And of course, as I said, the size of the particles matter. And then what elements do the rocks contain, and how do they work on different types of soils? Then the last thing is really important. Again, if we are going to be talking about new mining activity, are people happy about it, right? But just to reiterate, one of the trade-offs here will be the reduction of the use of fertilizers and pesticides. So are we bringing down food production cost? Are we increasing farm profitability? And are we therefore reducing barriers to take up enhanced weathering from an agricultural sector perspective? I'm not going to go into these numbers in huge detail. I think the key message here is that there are still really wide variations on what the projected cost per ton of carbon dioxide removed will be. And the graph on the right shows just how wide that is. I think if I look at the latest UK government forecasts, they say it could be £100 by 2050, and that's a forecast that's just come out in April. But yeah, the numbers really are still pretty wide. I think it also depends on whether it's gross or net. It depends on the efficiency. And as I said just now, it's not just the cost. You also can think about, are you offsetting some of these costs because your yields are going up, because you're lowering your need for fertilizer? I think what's very interesting about enhanced weathering is that early stage deployment could actually end up being cheaper than other greenhouse gas removal techniques, especially if you're using existing mining waste. But once that supply is exhausted and you have to start doing new mining, then your costs could go up. In terms of potential, again, lots of caveats around the data that's out at the moment. We still need to do these large-scale field trials, but if there are some estimates here that if you just looked at the Corn Belt in North America, you can see that there's an estimate of sequestering as much as 1.1 billion tons of carbon dioxide in the long run. So it's about 13% of the global annual emissions from agriculture. And as I said, in the UK, this is the range. 45% would be subject to more mining. And this, the numbers also, of course, vary on how much you can achieve in any 1 year and how mature the technology is, and so on and so forth. trade-offs and this terrible word co-benefits, which I would think in some cases actually core benefits, right? Because for me, I'm actually interested in this from an agriculture perspective, and the carbon dioxide removal is like the icing on the cake, as opposed to the other way around. But there is growing field evidence on crop productivity. There is the potential to reduce nitrogen emissions. It could work with, in our case, in the co-regen model, we are looking at enhanced weathering to work with biochar in tropical Africa. And biochar would actually accelerate enhanced weathering. There are unknown pollution risks and impacts on crops at high application rates. So, for example, in more acidic and organic rich soils, raising the soil pH may lead to accelerated loss of existing soil carbon. So you could end up offsetting the greenhouse gas removal benefits. And, if your source materials contain iron or steel slag, you could end up with metal pollution. And of course, then when your sediment runs off into watercourses, there could be detrimental impact on aquatic biodiversity. There's also, when you're mobilizing the rock dust, particularly if you're applying it under dry and windy conditions, you could end up with a local air pollution risk. But in other words, on its own or with other land-based greenhouse gas removal methods, enhanced weathering is nonetheless likely to impact farm yields, fertilizer and pesticide sales. And so, we have to keep doing the research and keep figuring out where this is going to fit in the bigger picture. The big challenge we have today is that we still don't have protocols to validate how much carbon dioxide is being stored and for how long. And frankly, to make it investable, we are going to have to start understanding this. The carbon credit story, whether you like it or not, it is, if there are carbon credits, that brings liquidity and that brings extra investor interest. However, how are we going to measure it? Will it be application tonnage? Some of these methods, there's a lot of work going on right now into figuring out what could work cost effectively, right? Because very key. And then with the full knowledge that a lot of things we still don't understand, including whether some of this carbon dioxide is going to get emitted later on. The other point is, of course, with any technology, for it to scale up, you need an enabling legal and regulatory environment. And today, here I'm talking about the US now, it's not that there are any laws stopping you from doing enhanced weathering, but there's nothing enabling it either. So, the practice, as I've put here, is covered by international guidelines which deal with geoengineering. Now, you could look at the Convention on Biological Diversity, but this US is not a party to that. You have the Convention on the Prevention of Marine Pollution by Dumping of Waste and Other Matter. You have the UN Convention on the Law of the Sea. Domestically, you could have things like the Clean Water Act, Clean Air Act, the Resource Conservation and Recovery Act, and so on and so forth. So there's quite a bit of work still to be done to figure out where this fits. And I'm just using the US as an example, but clearly these considerations have to be sort of everywhere. I think the three main things are, are you allowed to do it on the land that you're using? And I think in Africa in particular, security of tenure is a major challenge and risk. What sort of environmental permitting do you need to have? Of course, that will depend on the design of the project and so on, but does need thinking about, because enhanced weathering impacts everything: air, water, waste management, soil, etc. And then potential liability for damage. So this, just to round off, this is the checklist that I left the investors with. First of all, if you're looking at a company, why is it doing this particular net emissions technology? And I really do differentiate between the likes of, we have a lot of technology companies and airlines that are looking to invest in these technologies because they want to reduce emissions. And then you have the technology companies saying, well, here's a solution because we're doing this because we can. Where I'm looking at it from is we've got a food security problem and a mining waste issue. And that's really what should be that's what's driving my interest in enhanced weathering. I think you then obviously need to look at, so where are the rocks coming from? What will happen at the end of life? What type of rocks? How are they being transported and processed? And all the things I've been talking about, what size of particles and so on. How much is being applied and where? What's the soil type? How are you measuring impact, right? What are you measuring impact of? Carbon dioxide is turned into bicarbonate when rock reacts with water. And since it's soluble, rain flushes it to rivers and oceans ultimately. So, where are we going to measure it? And, for how long, and how are we going to keep measuring it? And of course, the money. You can't forget the money. If we are going to have to build new mining infrastructure, for example, how much is all of that going to cost? And the way I try to look at it is, if your total costs are going to be less than your fertilizer saving, so if you're going to save 1,000 widgets on fertilizer, but this thing is going to cost you only, if it's going to cost you 800 or if it's going to cost you 1,200, there's obviously going to be a very different way of looking at it. So that concludes my presentation.
Thank you, Aarti. Wow, that was super complete. So we have just about 15 minutes or so, and I'd like to, people are free to ask questions. I'd just like to ask you to be sort of attentive to the amount of time that you spend asking questions or commenting, and feel free to raise your virtual hand if you like, or raise your real hand. So the floor is open.
I can see some questions in the chat. Should I ask?
Yeah. Yep, go for it. Yeah, there's a few there.
Yeah. So the first one, is there a particular ore or mineral type that produces the byproduct to be pulverized? So I think the key thing is, so it depends on where you are in the world. The UK has, olivine and certain rocks. Here we've got, as I said, the basalt. So I think the key thing is these are silicate rocks. And then the minerals they contain will presumably, and this is where sort of I still need to learn more, the minerals will vary depending on the rocks. But that's the sort of thing that we need to be sort of understanding more and more. In terms of the energy demands, and is it just a natural by-process? So, yeah, as I was saying later on, and you may have put this question in before I said this, but it will depend, right? So it will depend on if you are taking rocks as mining waste, and those rocks may possibly even already have been crushed, then that's clearly less effort downstream because you're just picking up things, and in some cases they may even pay you to take them away. Whereas if you don't have mining waste and you're considering doing new mining, then yes, you absolutely have to think about what is the energy required to do the quarrying and the crushing and the transporting and so forth. So it'll really vary from place to place. And you need to put that into your calculator and figure out if all of these trade-offs and these costs and so on still make it viable, both from a financial and an environmental perspective. In terms of how it compares with biochar, so biochar is not there's no nutritional value in biochar. Right? Biochar is a soil amendment, and it's a stable form of carbon. It helps nitrogen get to the crops. It helps water infiltrate. Whereas enhanced weathering is really, the nutrients are key, right? So it happens to be a nutritious way of removing carbon dioxide. And then, Robert, the application on the decomposition of soil organic matter. I think I need to understand that a bit better. Well, understand your question. Are you saying if you apply rocks, is that going to cause decomposition? Perhaps you could, Robert, if you could ask that question. Okay, let's see if he comes back. And then Catherine, around mining waste being, yes, again, that is most certainly one of the considerations. You know, what is the mining waste, and does it contain undesirable things, right? So again, if you're looking at a project, if you're that's absolutely one of the things that we need to be thinking about. Wind pollution, how, right? So the way, in terms of the rock dust itself, I don't know if people have checked what happens if rock dust is carried into water. I do know that once enhanced weathering has happened, and once you've got the carbonate or the bicarbonate in the soil, it can and will also end up in rivers and the sea and so on. And it's then what happens to it at that point, right? Does it just dissolve? Does it go to the sea floor? And again, these are some of the things that it's only time that will tell us. It's only time and measuring this that we will have a really sort of clear idea. And do we lose carbon dioxide or some of the carbon dioxide over a period of time as well? And if so, how much? Is basalt? No. So there are other silicate rocks that work. And again, it'll depend on what your local ecosystem has. How responsive are mining companies? So right now, I'm not actually talking directly to mining companies yet. I absolutely want to include enhanced weathering in our offering as a consortium. But I think if I were to go and talk to any mining company about it, it would be with a big caveat that this is still, we are still learning about this, and that, in my own view, I think that any investment in this space, I think, I know governments are still funding and they must continue to. I think there's an opportunity for public-private partnerships as well, because if private companies are prepared to put in funding, great. But we're still understanding what the impact of this will be. So I think for the foreseeable future, I don't think it's impossible for startups to start looking at this or to be looking at this. And there are a few, as I mentioned. I don't think it's impossible for mining companies to be thinking about this. I think they should be. But everyone has to understand where we are today in our understanding of it.
May I put up that question? I had an opportunity to be with a few mining executives, and when we raised this as a possibility, it was actually, they were quite surprised, and they were immediately interested because they do have a CO2 problem. They do have a pollution problem. They have real serious environmental problems. So I have a hunch that there could be really a real interest there. Just something to contemplate, that there is a problem. They're having a problem which they're not yet thinking about in the terms of what you just described. And once connected to that, I saw instantaneous interest to say, wait a minute, that's interesting. Let's figure it out.
Yeah. Yeah. I mean, I think, I'd certainly at some point love to be part of these conversations. I still need to understand more about the rocks and the composition clearly, as I said earlier, we need to understand from the mining companies as well, what form is the rock in and where is it today and so on and so forth. So a lot of work to be done. But
the interesting is that there could be an approach that says, let's do an assessment of these different mining outputs and go to these companies and say, you know what, we analyzed, or together with your chemical engineers or your, like internal capabilities, we figured out that you have these resources that we can convert into whatever, right? So I think there's a learning space there and a collaboration space that is worth looking at.
Yeah, definitely.
Aarti, I'm curious, is there, you showed in one of the charts something like a more of a takeoff of this technology around 2040 or something. I'm just wondering if there's a window for when it's most useful versus other things that are in the pipeline for reducing carbon, for enhancing soil. So I recognize it has a rather unique kind of set of characteristics, but is there a particular time that it's going to be more or less useful as far as you've been able to tell?
So I think, how can I put it? I think, one of the things to think about, right? For planting trees is seemingly the most obvious thing for people to do, right? They'll say, oh yeah, let's go. But that's competing for land, and trees burn down, right? I mean, at the other extreme. So yet it's deemed to be from a technology readiness level is level 9, right? And biochar level 5, because despite all the terra preta and all the sort of Latin America and the West African sort of soils and so forth, we still haven't done enough research on its sort of long, in this very deliberate use of biochar, right? And you could go and talk about all the other greenhouse gas removal technologies and figure out what are the sort of pros and cons and where do they sit vis-a-vis each other. I think that from food, nutritious food, so food security, right, is already a challenge. And it's only going to become a bigger challenge. Population is not decreasing and the soils are not getting healthier naturally. So I would like to see this being accelerated, the research into it being accelerated, so that we really do understand this thing, for example, mining pollution versus and I have to say, when I did present it to the investors, quite a few of them were based in the US, and I said, the US has a problem today with its water regulations, right? I mean, you regulate for about 9 things, and there's like 10,000 chemicals in the water between some drugs and all sorts of chemicals that industry is using, and PFAS and so on and so forth. So I do think that there are some things that are really worth thinking about extremely carefully. I know I'm not directly answering your question, because I think right now I feel we've got to take the next few years to do some concerted research and come up with, okay, in this part of the world, on this soil, in these cropping systems, in this climate, you can do it this way, and in this place you can do it that way, or this is, in this place you can make it responsible for 20% of your carbon dioxide removal target, whereas here you can only have it as 10%. And I think I would like to see over the next, let's say, 5 years, some really concerted research and recommendations coming out, and then we start thinking, where do we deploy it and how quickly and so on. But for me, the food security thing is a huge driver.
Yeah, fascinating. So we have just a couple minutes left. Is there anyone who hasn't asked a question who would like to, or make a comment?
And I know there was a question on the kinds of rocks. I mean, there's a lot of data around the different types of rocks and what they contain, and nepheline and glauconite and things that again, I'm still sort of learning about. So the short answer is there's more than just basalt.
Yeah. Good. Thank you. Anyone else? Last comments? Okay, I think we're complete. Thank you, Aarti. It's fantastic. You actually gave us, at least me, much more than I expected. It was, I mean, not of you, but just the level of detail that you provided is pretty amazing. So thank you. And I look forward to continuing that discussion. Maybe we get you in the Wednesday morning session as well. So thank you everyone for joining us. And I really appreciate the participation. And I'm going to stop the recording now.